Alright, today we're talking about the final section of Chapter 5, 5.5, which is, it's titled Additional Identities, but we're really going to be focusing on two types of identities today. The first one is this one, going from products to sums, or maybe a product to a difference. The other one we're going to be focusing on is going backwards, going from a sum to a product, or a difference maybe to a product. But to start off, these are my product to sum rules. So we have one for sine times cosine, cosine, sine. We have a cosine, cosine, and sine, sine. So let's talk about applying them now. So we want to write this 10 times the sine of 5x times the sine of 3x as a sum or a difference, and then we're going to simplify. Now, if we look back at my formula sheet here, I provided a smaller one for us. Notice right now we have a sine times a sine. So if you look on your formula sheet, you'll see it's this bottom one, sine A, sine B. Now notice there's this pesky little 10 hanging out at the end, at the beginning. We're not going to be really doing much with that. That's just going to be kind of hanging out until the end. This sine 5x, sine 3x is what we're going to be applying my formula to. So let's write that out. This 10 is just going to hang out. So you have 10 times 1/2 times the cosine. Well, we got to determine what's A and what's B. Well, my A is going to be this first one, 5x, and my B is going to be the second one, 3x. So we have the cosine of A minus B, so 5x minus 3x, minus the cosine of A plus B, so 5x plus 3x. And then we need to simplify. So this 10 times 1/2 becomes a 5 times cosine of 5x minus 3x, so 2x, minus cosine 5x plus 3x, 8x. Now we cannot evaluate this cosine 2x or cosine 8x. So that's as simple as it gets. That's my answer right there. However, what if we want to do the cosine of 3 pi times the sine of 3 pi? If we were to look back at my formula sheet, we would see that there's one, which is cosine of A, sine of B, which equals 1/2 times sine of A plus B minus sine A minus B, which matches up with the problem I'm given. I have a cosine and a sine. So let's just plug in everything we know. So we know this now is equal to 1/2 times bracket the sine of, well, what's A and what's B here? My first one, 3 pi is A, and I get pi as my B value. So you have sine of A, 3 pi plus B, pi, minus sine of A minus B, 3 pi minus pi, end bracket. Now let's do a little simplifying. 1/2 sine of 3 pi plus pi is 4 pi, minus the sine 3 pi minus pi, 2 pi. Well, let's see what we have here. Notice I'm actually plugging in an angle here. The sine of 4 pi, well, that's in radians, that's an angle. The sine of 2 pi, that's an angle again. Let's look at my unit circle, though. Where am I at with 4 pi? Well, 4 pi is 2 times around the circle, and I'm back at the beginning. So really, what sine of 4 pi is the y value of that point, which is 0. So this is 1/2 times 0 minus sine of 2 pi is just 1 time around the unit circle, back at 0 again. So the sine or the y value there is 0. So this is 1/2 times 0, or 0. So whenever you're actually given an angle, 4 pi, 2 pi, you have to evaluate. You have to simplify down as far as it goes and get an actual number answer. So now we have the sum or difference to a product. So this is essentially going backwards to what we just did. Notice we have a sine plus sine, sine minus sine, cosine plus cosine and a cosine minus cosine. So you have a sum or difference for sine and cosine, two for each. So let's try these out a little bit. I want to rewrite cosine 5x minus cosine 3x as a product. So we have to determine which one we're going to use again. Look at my formula sheet over here. Let's get it so we can see all of it. There we go. Right now I'm dealing with a cosine minus a cosine, so we're going to be using this bottom one. So we have to figure out which one is alpha, which one's beta. And alpha and beta are just letters. You can think of them as A or B. To stay consistent, I'll keep them alpha and beta. But if you want to label them as A and B, that's perfectly fine. And now we just plug into the formula. So we have a minus 2 times, well, we have the sine of alpha plus beta, so 5x plus 3x, all divided by 2, times the sine of alpha minus beta, 5x minus 3x, all divided by 2 again, end bracket. So now we got to simplify it all down as far as it'll go. Well, 5x plus 3x, that's 8x, so 8x divided by 2, sine 5x minus 3x, that's 2x divided by 2, and then I can simplify one step further. This would be the sine of 4x times the sine of 1x. We'll use a hard bracket just to stay consistent. Now remember, I'm not evaluating any angles here. 4x is not an angle, it's a variable. X is a variable again, not an angle, so I cannot evaluate them. However, what if I'm given one that I can evaluate? Now you may notice right away, hey, sine of 75 degrees minus the sine of 75 degrees. So right off the bat, you would assume, hey, wouldn't this be 0? I'm subtracting itself, so it should be left with 0. But let's actually show why that is. So right away you notice I have a sine minus a sine. So let's write out that identity. Sine of alpha minus sine of beta. If you look back to our formulas, this equals 2 times the cosine of alpha plus beta divided by 2 times the sine of alpha minus beta, all divided by 2. So what's alpha and what's beta here? Well, alpha is always going to be whatever is in my first trig identity, or trig function, if you will. And my beta is the angle of whatever's in my second trig function. So they're both 75 in this case. So let's come down here. Let's plug everything in. This is equal to 2 times the cosine of 75 plus 75, they're both degrees, so we got to mark them as degrees, divided by 2, times the sine of alpha minus beta, 75 degrees minus 75 degrees, all divided by 2. And let's simplify. 2 times, well, cosine 75 plus 75 gives me 150 divided by 2 degrees, times the sine 75 minus 75, well, that's just 0 divided by 2, so the sine of 0. Thinking back to my unit circle here, more of like a unit oval, sorry about that. 0 degrees is, well, my starting point, and the sine of that is my y value there. So my y value here is going to be 0. So the sine of 0, that's just 0. Well, what's anything times 0? 0. So that is why the sine of 75 minus the sine of 75 is in fact 0. We're also going to be verifying some identities here. Now when we verify identities, it's not quite the same as proving an identity. We just need to show that the left side is equal to the right side. So when we prove, we always drew a line down, and we only ever dealt with the left-hand side. However, when it says to verify an identity, we can manipulate both sides. That's okay. So right away, I'm just going to deal with the right-hand side because I really don't know what to do with cotangent. I could write it as cosine over sine. However, that's not going to get me to this crazy sum stuff here. So let's deal with the right-hand side. So I'm still going to draw my line, however, I'm dealing with the right-hand side now. Well, notice we have a cosine plus a cosine. So I can use my identities here. I won't write them out again, you can look at them if you want to. But when we have a cosine plus a cosine, it becomes 2 cosine alpha plus beta over 2 cosine alpha minus beta over 2. Let's write that out. This is equal to 2, this is just my numerator, times the cosine of alpha, which is 3x, plus beta, which is 1x, all divided by 2, times the cosine of alpha minus beta, 3x minus x, divided by 2. And that's my numerator. Divided by, we have a sine minus a sine. So going back to my formulas, this is 2 times the cosine alpha plus beta, so 3x plus x divided by 2, times the sine of alpha minus beta, 3x minus x divided by 2. Now let's think and look at what we have here. Everything's multiplied on top, everything's multiplied on bottom. So anything is fair game to cancel. So I can cancel my 2's off. Notice I have a cosine, well this becomes a 4x over 2, and a cosine of 4x over 2. So those completely cancel. And we're only left with this stuff right here. Let's write that out. Which becomes the cosine 2x divided by 2, so 1x, divided by the sine of, well this is also 2x divided by 2, or the sine of x. And notice cosine over sine is equal to cotangent. Smiley face because we're done. Let's do one more. The cosine of the arcsine of 3 over 5 minus the arctan of 2. Well, we need to think for a second, what is the arctan of 3 over 5? And what is the arctan of 2? Those are just angles. So really what we have here is a cosine of an angle minus an angle. Or if we want to think of it, cosine of A minus cosine of B. Sorry, my apologies, just cosine A minus B. So this is going back to some old identities that I learned. We have the cosine of A minus B here. And if we remember back to, I believe it was 5.2, the difference identities, this is equal to the cosine of A, cosine of B, plus sine of A, sine of B. So it's important to know, hey, I know that the arctan of an angle is just the, my apologies, the arc, I gave away the answer. The arctan of a number is just an angle. I know the arcsine of a number is just an angle. So really, we have a cosine of an angle minus an angle, which is the difference identities for cosine. So we're going to use this arcsine of 3 over 5 and this arctan of 2 to set up some triangles. Let's draw an angle for A here, a triangle for A. So this is going to be my angle A. And since it's the arcsine of 3 over 5, I know that the opposite is 3, and the hypotenuse is 5, which hopefully you can recognize as the x value is going to be 4. Now let's also draw one for B. Well, arctan or tangent is opposite over adjacent. Let me think of this as 2 over 1. So my opposite is 2, my adjacent is 1. Using Pythagorean theorem, this leaves root 5 as my hypotenuse. Now, we need to think about what's the cosine of A. Well, the cosine is just adjacent over hypotenuse, so 4/5 multiplied by the cosine of b. Well, adjacent over hypotenuse, 1 over root 5. However, we need to rationalize that right away. Multiply top and bottom by root 5, so I end up getting root 5 over 5. Hopefully we can kind of start to do that in our heads and just not waste time writing it out. Plus the sine of a. Well, the sine of a is 3 over 5 multiplied by sine of b. Sine of b is 2 over root 5. If we rationalize that, we get 2 root 5 over 5. And from there, we can multiply top and bottoms. So you get 4 root 5 over 25 plus 3 times 2 root 5 gives me a 6 root 5 over 25. Now, we already have common denominators, so I have something over 25. Well, I have 4 root 5s plus 6 root 5s gives me 10 root 5s. And from there, we can simplify down. 5 goes into 25 5 times, goes into 10 twice, so we get 2 root 5s over 5. And that's my final answer. So the key to this one was understanding, hey, arcsine is an angle, arctan is an angle, so I used my cosine difference identity, split it apart, and then I had to use the fact that I knew that this is an angle A, this is an angle B, to set up some triangles. Now I kind of glossed over the fact that, hey, they're both in quadrant 1. Hopefully we can recognize that using the restrictions, using my inverse or arcsines, or arc trigonometric functions, to know, hey, arcsine is in between negative pi over 2 to pi over 2. It's positive, so it has to be quadrant 1. Same thing with arctan. And then from there, I just used my triangles, plugged in, figured out what the sines and cosines were, and then simplified. Go ahead and write your summary and any questions you have, and please start to take a look at this assignment down here for class tomorrow.